In this video, we'll talk about the reasons for using encryption and when it is called for, and how LUKS operates through the use of a crypt setup. Set up and use encrypted file systems and partitions. Configure the system to mount encrypted partitions at boot. Okay, let's begin. Why use encryption? Encryption should be used wherever sensitive data is being stored and transmitted. Configuring and using block device level encryption provides one of the strongest protections against harm caused by loss or compromise of data containing hard drives and other media. Modern Linux distributions offer the choice of encrypting all or some of your disk partitions during installation. It is also straightforward to create and format encrypted partitions at a later time, but you cannot encrypt an already existing partition in place without a data copying operations. LUKS. Modern Linux distributions provide block device level encryption mainly through the use of LUKS, Linux Unified Key Setup. Using block device encryption is highly recommended for portable systems such as laptops, tablets, and smartphones. LUKS is installed on the top of a crypt setup, a powerful utility that can also use other methods such as plain DM crypt volumes, loop AES, and a TrueCrypt compatible format. We will not discuss these alternatives, as LUKS, which was originally designed for Linux but has also been exported to other operating systems, is the standard method most often used in Linux. The DM crypt kernel module uses the device mapper kernel infrastructure that is also heavily used by LVM, which we'll discuss later. Because LUKS store all necessary information in a partition header itself, it is rather easy to migrate partitions to other disks or systems. LUKS can also be used to transparently encrypt swap partitions. Crypt setup. Basically, everything is done with the Swiss Army knife program crypt setup. Once encrypted volumes have been set up, they can be mounted and unmounted with the normal disk utilities. The general form of a command is a crypt setup, option, action specific, and a rather full listing of possibilities can be generated by crypt setup dash help. Crypt setup dash help. Right. Using an encrypted partition. If a partition dev SDC12 already exists, the following command will set up an encryption, make it available to a LUKS, format it, mount it, use it, and unmount it. First, we need to give the partition to LUKS. We do sudo crypto setup LUKS format dev SDC12. You will be prompted for a passphrase that will need to open the use of the encrypted volume later. Note that you only have to do this step once. When setting up encryption, your kernel may not support the default encryption method used by crypt setup. In that case, you can examine proc crypto to see the methods your system supports, and you can supply a method as in sudo crypt setup LUKS format dash cipher AES dev SDC12. You can make the volume available at any time with the sudo crypt setup dash verbose LUKS open dev SDC12 secret. When you will be prompted to supply the passphrase, you can format the partition sudo mkfs.ext4 dev mapper secret and mount it sudo mount dev mapper secret mount, and then use to your hard's content just as if it were an unencrypted partition. When you are done, unmount with the sudo unmount mount, Then remove the association for now. Mounting at boot. To mount an encrypted partition at boot, two conditions have to be satisfied. You need to make an appropriate entry in etc fstab. There is nothing special about this, and it does not refer to encryption in any way. This can be as simple as this. Dev mapper secret mount ext4 defaults 00. You also need to add an entry to etc crypt tab di etc fstab. You're gonna do it dv mapper secret anti ext4 default 00. Alright, save the config. We're not saving it now. This is for demo purpose. Then next one you need to edit is this etc crypt tab. You do dcret dv sdc go. That's it. And then save the config. We're not saving it over here. Okay, this is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.